Good morning, ladies and gentlemen. This is Marcos Garcia, Cloud Solution Architect, and with me I have Ron Marshall, Senior Solution Architect. Thank you. So we can go now, right? I'm based in Montreal, but I've been invited to talk to you guys here, and Ron is native here in Toronto. We're going to be discussing today some aspects about operating multiple clouds and how to connect them together with Red Hat technologies. And in long story short, this is what you're going to learn today. Hybrid cloud means containers everywhere. In this case, our containers offering is called OpenShift, which we're doing kind of a deep dive on the other room. We're going to show you how to manage everything with platforms. I'm going to show you also why and how to standardize on Ansible for all your cloud needs, and how to interconnect data silos, both from the network and storage perspective. Finally, that will enable you to have a true, seamless, unified experience with OpenShift. And in fact, if you want to put it in on-premise because of reasons that you will see, why that combination of OpenShift and OpenStack, which is a bundle we sell, works great. Then, if further ado, a couple definitions. You were here this morning, you saw some definitions from my colleagues. We define multi-cloud as a combination of multiple clouds. In this case, Amazon, Google, Azure, Ali, SoftLayer. But they are not necessarily together. They kind of work in isolated silos. Hybrid cloud is a strategy in which you actively try to connect those islands to allow your developers and your workloads to move, maybe to share data, to minimize the risk of downtime on one side, to also expose resources that are hosted on your data center, what we call mode 1 workloads from your mainframe for your Java Enterprise workloads, how to connect all that together and have it all managed with a single IT department. For some, cloud has multiple meanings. I'm not going to talk about like Salesforce or things that you actually run like Office 365. From an IT perspective, cloud can have two meanings. One is the infrastructure aspect, so the one where you rent capacity from Amazon, from Azure, from Google, and you execute your workloads there. This is like an infrastructure platform. The other definition would be as an application platform, in which you use cloud to be more agile when delivering your applications and delivering solutions to your business. Why companies have been to the public cloud? Those two reasons are very good reasons to get an infrastructure or an application platform. But the real why that we were discussing earlier, like on the conference, on the presentation from Mike, the real why is to improve agility, to improve security, which this one is kind of hard to achieve, to be honest, and improve staff productivity. The security one, it's a weird one, because it's also the key reason why people stay on the data center, because they feel like the walls offer protection. And the moment you get rid of those four walls of the data center, then hackers will come or something, right? So how you are inherently secure on something that is not within your data center, that is running somewhere else. That's what makes some people also averse to public cloud. That's why one of the main reasons why people still have data centers, why still vendors such as VMware, Dell EMC still making big numbers, why we still provide software to run on servers that you own. From those who run software on their private clouds, their challenges are kind of the same we had with visualization and bare metal management, but the benefits of putting this next generation software called private cloud, in our case it's OpenStack, is that it's easier to get compliance, it's easier to gain control by offering policies, flexibility as well to offering different policies to different departments, and of course data management, as in I own the data and the storage where my digital assets are running. In a summary, why private cloud? It also makes sense. Control, cost, privacy, no lock-in, and self-service. Otherwise, we will be calling it just virtualization, right? That's a key difference. Old school virtualization, you still have to talk to your IT help desk. When you call it private cloud, it's because it becomes self-service. It offers like an ecosystem of open source tools. It still allows for privacy, all under the same control of the IT department. Combine those two ideas together, that's the hybrid cloud dream. It's kind of a nirvana wish. We all want to get hybrid where we can combine the resources where we want. So we can have to use and combine those two technologies in a unified manner. So we share the resources across all the consumers and all business units. We provide a way to consume that in the same manner. You will see later that containers, that's the answer. And still adheres to open source best practices, as well to your internal standards. course, Red Hat, we believe we are in the best position to offer the best solution for this problem, for this challenge, and it's all based on Linux. You may have seen some messages that we published on marketing collateral. Containers are Linux. So if I put Linux everywhere, right, Linux on bare metal, Linux on VMs, Linux on cloud, public or private, I would be able, in theory, to run containers everywhere, right? That's the mission. And we are the enterprise Linux vendor, the preferred partner worldwide from the Fortune 500 to the smaller companies to put Red Hat, a enterprise-ready Linux distribution everywhere. With that in mind, let's imagine a world where OpenChip is the thing that unifies all infrastructure platforms. And OpenChip is the one that offers application developers the runtime, the standard runtime, to do their job. And we are also offering you, as the IT administrators, the operators, network admins, a set of common standard tools that also work across the hybrid cloud. In this case, CloudFront, Ansible, Satellite, or Jenkins for OpenShift, for instance. And it all works on either private cloud like OpenStack, private virtualization like Red Hat virtualization, or VMware, Amazon, Azure, Google. So for you to have an idea, and I'm going to run this pretty quick, this is what we'd like to achieve.
As promised, we're going to be doing more technical demos in here. You'll see some real screenshots.
Sorry, I forgot to that. This is going to be technical and hands-on, but I just have a couple of videos of 1 minute long. This is what we'd like to achieve. Developers who have the same user experience on Amazon, that's on the right side, your left, sorry, your left side. And on the right side, it will be running on OpenStack. But the developer kind of has the same, the same tooling to deploy, in this case, a Ruby application. So all these command line tools, you would like to know more in detail, that will be the other room. Here we'll be talking how to enable this user experience from an IT perspective. Okay, you see, same workflow. And then with CloudFront, which is the thing I'm going to be demonstrating later, how you can see in the same format all the clouds and all the resources. This is what we're going to be diving in a minute. So as we kind of already covered, multiple clouds is great. They all have different technologies, different names, different vendors, different prices, different challenges. But if we allow our customers, our internal development teams or marketing teams to be pushing their stuff on each cloud in a different manner, we're creating this heterogeneous nightmare. And probably some of you have already heard the word shadow IT, where consumers internally, they consume IT resources elsewhere, and we don't know about it. That's why probably all of you have some sort of public cloud usage in-house, and probably why all of you don't know at this point how many cloud instances are out there, and you're kind of scared when at the end of the month you will receive a bill, thousands of dollars, and you have no idea where this comes from. That's a problem with shadow IT, the cost one, as we saw earlier, with also other issues. The management part of it, when everybody's developing skills and expertise, you will have the Amazon expertise, you will have the Google expertise on different silos. That's not good from a culture perspective, not a productivity one. If you have an IT division, IT should be the owner of that subject matter expertise. Also the business value, right? If people are doing cost optimization in one cloud, but the others are not doing cost optimization, there will be some business opportunities lost there. The tooling that we're going to be showing today, it will be OpenShift for the containers workloads, Ansible for the tooling, the low-level tooling. The high-level management will be done with CloudFront, and the business value, it's up to you to reach. But why management should be hybrid? Each cloud vendor has its own management tools. The Amazon portal, the Azure portal, OpenStack has its own portal. By having all these disparate systems, you are also allowing different automation policies to be implemented. Let's say you have a security policy in your company due to regulation, PCI DSS, STIG, healthcare regulations. You will have different implementations of the same business logic in different technologies. That's kind of harder to audit. So your audits later will be, in the case, let's say you have 4 technologies, you will have 4 times the cost and time to do a single audit. If you go hybrid and you have a same management tool to do that, then it becomes a single, we call it a single pane of glass, where you would be implementing and enforcing policies and automating the logic of your business. That should be a winning point, right? Now imagine how would it look like. Let's say you have this hybrid management and you want to expose services to your internal consumers that they could run on any cloud. The first step would be to show them a service catalog. Hey, if you want a VM, you want a application development environment, or if you want to deploy a web server or a database, click here. From there, we will do the deployment using our best practices and our own policies, our own security definitions on the cloud of our choice. We will do all the plumbing, as we will show later. We will automate the deployment and the management of the patches and the security things that we will see later this afternoon, by the way. There is a dedicated demo on that aspect, on the security handling on the hybrid cloud. And all that technology underneath, it uses the same language. We strongly believe that Ansible offers the same universal language. I don't know who here knows what Esperanto was, but there was a dream of a person who wanted to have the same language worldwide for travelers. Nowadays, it's English. And I'm Spaniard, so I can tell you that in English. And that's the universal language. So Ansible is like the English. It's the business language, right? So with Ansible, you can do everything. And you can also proactively monitor and identify issues. It's something that we're going to demonstrate later this afternoon, I think, with Chris. Yes. We're going to show how to patch and resolve issues with Ansible as well, thanks to insights as the source of intelligence that will send you the playbooks to fix those issues. All that is fine, management-wise. I love management. Went to business school, and we all look like a very managerial, but when rubber hits the road, you have to actually go and implement stuff. And the first challenge I guarantee you will be the network plumbing. And that's something that managers really understand. Networking, it's hard. Even though there is a lot of marketing on SDN and SD1, it's still hard. We're trying to fix it by putting a unified layer of networking across all products. It's called OVN. It's based on Open vSwitch. It has the word open, meaning it's open source. It's an open source SDN implementation that works across clouds. You will see that later as the product evolves. We're kind of launching it this year. You will have the same SDN layer on virtualization, on private cloud, and on public cloud. Okay? But that's a very technical matter. You guys want to talk more about it, meet me later for lunch. But that will be what we're providing for free. If you want more further advanced use cases, look in the marketplace. Go Contrail, so Juniper, Cisco, VMware has a solution. Actually, they bought an SD1 vendor, same as Cisco, Project Calico from Tigera. Those are the few I've looked at it. They all offer means to interconnect clouds. Okay? That's definitely worth trying how to do a better job of connecting different clouds and workloads and apply policies while doing so. Second step, second challenge is storage. Each cloud vendor have different storage solutions. Most of them implement 3 categories, object, file, and backend for VMs, block storage. How do you unify that across 3 different vendors plus your private cloud? We have solutions for that. In particular, Gluster, we will see that later. Actually, there are some demos on container native storage that shows how Gluster can be the unifying layer of all your storage providers. And the language to access that storage can be different. Nobody's saying that all your developers should be implementing S3 stuff, because you also have old products that require files. You may have databases that require partitions. That's fine. Let's provide a common system to unify the storage, but let the language be different according to the workload. Don't forget, geo-replication is important. You may have Amazon East and Amazon West, but there is a latency across sites. So if you want your workloads to be slightly performant, you have to look for a solution that has at the same time data localization and geo-replication. And that's something we can work on. So now we have seen a kind of an overview of the challenges. I would like to introduce you with what we recommend the first 3-4 steps for you to onboard on the hybrid cloud journey. Again, the situation is there is public cloud usage in your companies, I guarantee you that, but you may not know about it. So the first step is to see and recognize the problem, right? You cannot solve a problem that you don't know about. You have to recognize you have a problem first. So let's connect all our clouds, at least from a visibility perspective. For that, we have a tool called CloudForms. I kind of call it multi-CloudForms, because what it does, it connects to multiple providers, and we'll show you what's going on from a unified perspective. It also connects to private cloud / virtualization. It actually, fun fact, CloudForms probably you don't recognize the name, but ManageIQ is the project, the company we bought many years ago, and that was named one of the best solutions to manage VMware. Back when cloud usage was not really that popular, ManageIQ was excellent at managing VMware. We added functionality so it manages public cloud, and now that's what the product is today. It's called CloudForms. The most recent release has improvements on what it does on each cloud. The most noteworthy is smart state analysis. I will show you that in a minute. It basically looks inside each instance of your public cloud and looks at what's going on without any agent. So even if you have projects in production from the marketing team, they have a website you never heard about, you just give in the credentials and you see what's going on, like 100 VMs. Don't know what's in it. Smart state analysis will connect, make a snapshot of the hard drive, check the content, and tell you the packages that are running there, the files, the users, the permissions. You can run this scan weekly or daily. You can create alarms of what's going on. So that's an important factor. And the VMs are running smoothly in production 24/7. Nobody knows that you inspected them, but you have a report. So from zero visibility to full visibility in just basically one click. You just have to add the credentials to Amazon. Same thing with container platform. So you give the credentials to your OpenShift platform. You give the password to CloudForms. It will see what's going on. Thousands of containers and hundreds of services being moved around. You will see all that in CloudForms, and I will show you an example later. Same thing with OpenStack. It connects to it and checks real-time what's going on. And as I mentioned, virtualization management, plus a new feature, physical management. We have created a new API. The first vendor is Lenovo, Xclarity. CloudForms will talk to that thing. I will tell you exactly the rack ID, the MAC addresses, the blades that you're using, if there is any warning light, any LED saying there's a hard drive error and whatnot. And you will see everything from the container to the node, to the VM, to the host, to the physical blade, which rack it's connected to, and you can create a signal, like an alert, something wrong with the hard drive, so my container will be affected. How crazy is that? Like, how many layers are we traversing, right? So CloudForms can see everything. Now I'm going to show you quickly 4 quick demos, and I have here my script. These are the screenshots. We will see the dashboard, the report. We will see topology view and the dependency chains. We'll see smart state analysis, and one control policy that's going to be pretty quick. So far, so good?
Any questions?
All right. This is CloudForms. CloudForms, this is the audience. Nice to meet you. So this is a tool that we sell for cloud management, but you can get that for free included in certain products, such as OpenStack and OpenShift. We're also offering now with Red Hat virtualization. But definitely, if you want to manage VMware, you want to manage public cloud, that's a product we sell support for, and we help you also to build the dashboards. It's fully customizable. You can click around and add all other reports. So let's follow the script. First, we're going to see the guest OS chart. So this is what's going on Amazon and on Azure. I see a lot of CentOS. Somebody's not using my Red Hat subscription. There are 12 Red Hat. That's good. There are some Amazon Linux. Again, they should be using Red Hat, right? And some Ubuntu. Oh, that's a really bad one. Kid you not, I was an Ubuntu person before. Then I got brainwashed. So Azure, the story repeats a bit. So RHEL is number 1, but then we have, what is the Windows one? I had the Windows data center. There was a tiny one.
It crashed.
There you go. I also see top CPU consumers, the number of VMs by flavor. I've put a couple other reports. Recently discovered VMs. That's not really useful because I discovered like 20 in the last day. Who's using the most storage, etc. All this information can be seen as a report, like a tabular format. Config management. Let me show you one. Report. Config management providers. Let's see this one. What's telling me? Monthly VM count per provider. I had, Gerald in the other room is using, the peak usage he had was 47 VMs over the last month. He was doing a lot of tests. Now he probably is not using that many. I'm going to show you in a second real time what he's using on the other room. And he told me not to break anything, by the way, but I'm watching what he's doing on that room on Amazon with OpenShift. Schedules. So I can run this report that's tabular format and get a PDF by email. I put it every month, but I want to change it. Like, go ahead and change it. I want a report every day at 9 a.m. to see who is using my cloud and send it to the manager and to the user and whatnot, right? As you can see, there is a report builder. There's a dashboard builder. So it's up to you to create the reports you want, right? There's a framework to do your own. We recently added this timelines view that I kind of like. I haven't played much with it, so timeline operations. It will show me like an horizontal bar of what happened over the last time. I can change the time frame.
And Marcos, we can provide a reports part of this just for people who want to look at reporting without any control, right?
Absolutely. I mean, the user management, so you have different layers of privileges, right? Your CTO should be able to see everything, but your manager of a certain project shouldn't be able to see absolutely everything. So Cosmos has a very powerful role-based access control mechanism, and plus the taxonomy. You can tag resources and providers and connect also with VMware tags, with the Amazon EC2 tags, combine all that, and have your unified view of what are my resources, who they belong to, what is the purpose, development, production, testing, and build the reports based on that. Right? So again, full visibility of what's going on. Here, just telling me that, when is this? 14, that was a while ago, right? So there was a virtualization, a VM started, another that was stopped. So you see this is a kind of a timeline that you can change the scope of view. Anyway, just a new menu we just added. Next part of the demo, I'm going to show you the containers part. Again, that's the demo that's running there on OpenShift. Containers overview. You see there are a lot of menus because there are a lot of resources in IT, right? I have VMs, I have networks, I have storage across clouds. So this is, there are two providers here. I'm going to just show you the one from Gerald. This is the one he's using now. So I haven't enabled the CPU collector because he told me not to. Pretty much, yeah. He's running a small cluster. If I add that, it will involve a Prometheus cluster that he doesn't have the resources right now, so we just disable it. He's running 4 machines. Let's click on this one. It's telling me a lot of information. So which region it's running, what size of VM is running, what's the operating system, when it was created, the size of it, if it was verified. We haven't enabled compliance checks, but I will show you later what's compliance in this meaning. What does it mean? And this one, I love this one. This is an OpenShift node, but if I click here, I see the Amazon instance. And now I'm no longer on the container world, and I'm on the VM sort of world. If this was running on VMware, I would be now watching the VMware panel. This is information, this is Amazon specific. But remember, I clicked on the OpenShift one. And when it gets completely crazy is when I go and show you the topology view. Let me show you this one. This is even crazier. Do you know how many containers can be running at any point in time? Like, expect thousands. Yeah. And Cloudrunner will see everything. And when I click and see the topology, you'll see crazy stuff like this. This is what's going on right now on my environment. So I'm going to disable a bunch of information. I don't need to see the networking part. I just need to know how many containers are running on all of my nodes. It's basically crazy. Just going to limit it to pods. So this is the one from Gerald. He has one OpenShift cluster. This is my cluster, which is down right now. So he has one physical machine on Amazon that is also a OpenShift node. This OpenShift node has a bunch of containers, API server and whatnot. I don't know what he's doing, basically. But that's the point. I'm an IT manager. I don't know what my developers are doing. I see it, though. I'm watching. So if he goes crazy and starts putting extra large instances, I can get an alert. Like, chill down, right? If you want to play big, I have a cluster idle on my data center. Go and do containers on my data center. Whenever you know what you have to do, then put it on the cloud, right? So that's the point. You see everything. Another thing that I see, the content. Container images here. So Gerald is building his own images. He's not using like, Apache standard or something. He's doing crazy stuff with Roar. He's putting latest JavaScript code on patching containers, last generation and whatnot. I had one guy last week doing a .NET demo. And it was like, fine, have fun. I'm gonna inspect it though. So we ran the policy, and then we saw here, configuration. I saw that he's using 500 packages from RHEL. One of them is .NET Core, whatever. And I run an OpenSCAP result that Lucy later will show you in detail all this, what the meaning of all this. But I see what they're doing. And actually, it may take a while to download. This is a one, I think it's 10 megabytes big HTML report. Let's give it a second. Actually, I have the OpenSCAP downloaded already. Here, this is the OpenSCAP result. This is what it looks like.
It's a big file.
It's a big HTML. Oh, there it is.
Okay.
So that .NET image that I was telling you about has one security issue. Let me fail. This is it. This is the patch that they haven't fixed on their container, and they're running it on the cloud. I don't know what it is, honestly. The important thing, I can know it. I've seen the content of the Docker image that was just pushed on OpenShift by a developer on the cloud. And still, I can see what's going on and if there's any risk for my company. I think that's it. I'm going to show you now smart state for a regular VM. So let's stop with the containers part. I'm going to show you cloud, because many things will not be still available as containers. So you will still be running instances for a while. This case, I'm going to show you a Azure VM that I booted with a service portal catalog that I will also show you in a second. This one, we did a smart state analysis, which again does a marketing word for scanning the VM and looking at the packages that it has. So I click here on instances. And by the way, in production, you will not run CloudForms in a single instance with 4 gigs of RAM, which I'm doing, which is kind of explains the nature of it. In production, you can put as many VMs as you want. You don't pay for the CloudForms VM. It does require good storage for the database, which I'm not. I have a standard class in Azure. Packages here. So I discovered the content of a RHEL VM on Azure without awareness of the VM owner. Okay, the VM owner booted up from the Azure portal, and 10 minutes later, the CloudForms scanned the content and gave me a report. And if there's any package here that is vulnerable, I'm going to show you now what's a control policy. Like, remember OpenSSL Heartbleed? Do you all remember that one?
Yeah.
Heartbleed? There was a certain OpenSSL version, actually any version before that one would expose your e-commerce application to all the hackers in the world, right? So we had a couple policies here. Do I have the SSL? Shell shock. That if the instance contains the package bash and sorry, this is shell shock. This is not. This is another one. This one, anyways, just a different vulnerability we published, and the root cause is from a certain version of a package. And we wrote a rule, the expression here, as a policy, and we go, once we've written this thing here, then we go to the provider, let's say Amazon, and we change the setting. You see this little shield, manage policies, and we would enable the shell shock thing, was demo shell shock. Just enable that. This will enforce the policy. So from this moment on, any VM that boots and has that vulnerable package, then I can create an action. Actions could be just send me an email, tag the instance, or even go and shut down the instance. Email the owner, retire them, or make a snapshot. You can make all the actions, anything you want. And that should be it in terms of CloudForms demo. I'm going to move ahead with the presentation. Again, just a quick summary of what we saw on the policies. Policy profiles are what you apply, but then you can create actions and generate alerts based on that.
So Marco, just to recap what we saw there, we saw a single managing control panel managing VMs and containers, and those are running in Azure and Amazon.
Multiple regions as well.
Multiple regions.
So had Canada and Virginia in this case. Okay, so that's a personal challenge, by the way. When I go to Amazon, I have like 16 regions. If I ever make a mistake on my scripts and I put something on that different region, I don't see it on my panel. For those of you who haven't seen the panel, you have to literally change the drop-down to make sure that you are not forgetting anything on Canada. Now you go ahead and do this 15 times. Solution, just put the credentials on CloudForms. It will tell you something going on. Once you see everything. Yes, question?
So on the CloudForm on a hybrid environment, where do you have the CloudForm instance running?
That's up to you, right?
So we'll repeat the question. So the question up front is, when you're running CloudForms for a multiple environment, where does CloudForms run? And
so if you wanted to manage your VMware cluster in your data center, there has to be a CloudForms there because of network credentials. It has to be able to reach it. But the cloud, it's a cloud, it's on the internet. As long as the CloudForms has access to the API, it can see everything. It doesn't require special permissions. Now, if it makes more sense for you to launch CloudForms on Azure because you have $1 million of free credits, that would be my guess. I'm running it on Azure because I have free credits. So it depends to you. It takes RAM, it takes CPU, it takes disks.
So how are you, like, okay, you are on AWS cloud and you are on Azure cloud, and you are running it on Azure cloud, and then you are accessing the AWS instances and other VMs
Yep.
through an API call?
Yeah. So how does CloudForm connect to every public cloud? It's just via the API. HTTP request to a public endpoint, public DNS. There's no special network connectivity for the management perspective.
did I see another question back there? Somebody else?
That's a good question, and thank you for asking. It does report on cost, but your vision of costs, not the real bill and the discounts that you will get and sustained usage and spot instance and whatnot. You do model what you think are the costs for chargeback. Because you are exposing CloudForms to departments in IT and developers and whatnot. You will put a hourly rate for CPU, storage, and memory, and network as well, have 4 drivers. You can assign fixed cost and variable cost, and you put a dollar amount. And you will get a report on that monopoly dollar cost. But you will not get the real-time connection from each vendor, like real-time monitoring of the usage. Because it's very complicated, especially with Amazon, because you have, let's say, sustained usage discounts, you have spot instance pricing, and there are companies who try to do so with product-specific solutions. And even then, it's very hard to catch up with the changes they do in billing. They change their billing model once a month, easily, every cloud vendor. We just say, you know what? Expose to your users a model in which this service costs $1 an hour and $1 the gigabyte of storage, and as long as you recoup your cost, you're good, right? But that's the caveat. It's very hard to find in the market any solution that does real-time billing across the cloud. There are some that try to, but they always play catch with the cloud vendors.
Compliance rules, can we set up trend-based rules? Like, because we have the historical, if change or utilization has moved past 20%.
Question is on compliance, about trends, about capacity and usage. Let me get back at you later, but we do collect capacity and usage trends. We can react on certain thresholds. In terms of policy, the module you saw there in particular, I'm not sure. You can create an event and an alert, but I think you should connect that alert to another policy. So like create a custom alert, and that does the custom alert as a label, then they would trigger the policy. But I didn't show you the capacity and usage, but there are like graphs and whatnot for each provider. Moving on, once you see everything, and your internal customers, they all know they're being watched by Big Brother, you have to give them something extra. Because they already have access to the cloud portal, right? What should we give them? Ease of use. That's the easiest trick in the book. Cloud is kind of not hard, but if you have 4 different clouds and there is security risk, nobody's really comfortable putting their workloads on the cloud, despite you may think the opposite. If I'm a developer, if I know I could get fired if my database gets hacked on the cloud, I much rather have IT to bless the database settings, right? So I would expose create a database on the cloud service to the developer, and they would click on a button, and they would get their cloud database secured by IT. IT would have put security groups, firewall settings, VPN settings, all that stuff in place, so the database is not easily hacked, right? So that would be the idea of a service catalog. You see here an example. I will do a demo on one in particular. Also, beyond ease of use, you're also giving them convenience and accelerated delivery. If in the past it took you 3 weeks to deliver a VM with a database on VMware, if you could give them in 10 minutes a database on either Amazon, Azure, on VMware, or OpenStack, developers will be probably happier than they were. So from the moment they send a request to the IT team to the moment they get an email with here's your database connections, your JDBC settings, username and password on a properly secured and tuned setting, they will be probably happier, and they will call you next time instead of just going to Amazon and launching something, right? So you give them something in exchange for that big brother surveillance, right? So the moment they go with your system, you will be in full control of what's going on, and you're kind of effectively killing on the long term the shadow IT trend. You can see here an example. This is from another presentation we have, in which by looking at the workflow of steps required to do a IT task, you automate the ones that take the longest, and you put a service portal item. In total, you could deliver services in 10 minutes max. Now, how are those users using the cloud today? Probably they already have some automation. Classrooms has its own automation, and I could show you that later, but what we strongly believe is that Ansible should be the tool, the lingua franca across all automation languages. Developers probably are using either CloudFormation templates, Azure orchestration templates, Terraform scripts, or other sort of tooling. Ansible can integrate all of them. The Terraform one is actually something we launched recently, so it would be Ansible calls Terraform, and that's the one calling the resources. But Ansible has some nice tricks on its hat that we can abstract the cloud details, and you will see it. You will see this in a second.
I'd like to ask, are people seeing Ansible in use in their organization? Just with a show of hands, are people seeing our organization? Thank you.
For those who don't have Ansible yet, I invite you to watch my colleague's presentation later. We're going to do Ansible for Windows, network, and Linux, right?
Yep. Yeah.
The workflow you should be automating is something like this. It's not just about delivering a VM. It's also integrating it with your firewall, with your Active Directory, integrating it with your alarm system. There are multiple steps, right? So that workflow, that's where Ansible excels. And the fact that you have the same tool to do all these steps versus calling and trying to integrate different tooling, that's an advantage, right? So your service catalog item, it would not be just boot a VM and put like MySQL, would actually, again, create the registry with the same DB, put the firewall settings, change the DNS, etc. Right? All this complete workflow under your IT control. And that's the demo I'm going to show today. This is my last and big demo. Let me launch it quickly, because it takes 5 minutes to provision, and then I will tell you what I'm actually doing. So I'm connecting to Classrooms as a regular user. I'm user, name. Service catalog, I have 3 choices: simple rel on Amazon, simple rel on Azure, or launch a 3-tier application that I'm going to tell you what it is on Amazon. Just going to go quickly and do it. All right, and here I can just watch. The Classrooms service portal works under the idea of a order. It's kind of a shopping cart, which I forgot to click, by the way. I should do the order. There you go, important.
Don't forget that.
Otherwise, it will take forever.
Don't forget to check out. It's in your basket.
It's checkout, right? You have a shopping cart, you have to check out. What it's going to do is this topology. It's going to create 3 instances on Amazon. 2 will be JBoss application servers and 1 PostgreSQL database. They're going to get proper security groups. They're going to be all part of the same VPC. They're going to be put under a Elastic Load Balancer that I created manually before, so I can have the same DNS. I don't have to mess around. But Ansible could create the ELB as well dynamically. It will register everything, put the health checks, deploy the application, load it up, connect to PostgreSQL, initialize the database. All these things are happening under the hood. And it's all requested from Classrooms. And at the end, the 3 VMs that are registered are flagged as belonging to the user, And at the end of the month, I could charge back. I could charge them back like $1 an hour for the consumption of those resources. Let me show you from an admin perspective. Now I'm back to Classrooms, but I'm again the administrator. The other website you saw, that's the user interface. It's very simple. The admin interface has everything. I'm going to see what are the services that are currently being provisioned. I see there is a launch ticket monster that just got requested. There are still no VMs. VMs or instances, it's the same thing. And I see there is an Ansible playbook working under the hood. What it's doing right now, it's launching the app instances. It already launched the DB instance. That means if I go to Amazon on Virginia, there's at least one VM running already, or there are 3 already. You see there are 3 VMs that just popped in. If I go back to platform, sorry for the quick changing here, and I refresh, probably it will tell me that there are 3. There you go. The app instances are all running. It's just waiting for them to boot up. Once they boot up, Ansible will connect through SSH, deploy the software, configure it, take the host names, like for instance, the database host name, the one that we just created, it will be written on the configuration file of JBoss as the data source. If you're curious, I could show you the playbook, but I think I will be too technical. But there is a GitHub repo where you can see this playbook. Loading. OK, so there are 2 or 3 already up and running. This is the playbook. I measured it is 5 minutes, and I have to talk through 5 minutes. So we are on the step, probably wait for the stage to come up. This is Ansible. For those who haven't seen it ever, you will have a full session on Ansible later. It's gonna collect the instance information. It's gonna put it all back into Classrooms. This is like the CMDB approach, right? We just discover something on my IT environment. I have to properly put it on the inventory. That's what I'm doing here. Refresh the provider, a bunch of stuff that has been done with Classrooms. We're registering it with something called a callback. Once everything is kosher, we're going to expose a service. So from Classrooms perspective will be done. Ansible keeps working a bit. It's going to configure the security settings of Postgres. This is the security part where we secure so nobody can hack this database. We're using a role. Roles are something that will also be explained later. So PostgreSQL is set up according to the best practices that we have selected. And finally, we're deploying JBoss, and it's collecting all the information it requires from what we call the Ansible environment, including the address and port and user of the PostgreSQL database. Should be done. So there you go. 3 instances have been created. And the load balancer, I don't think it will be ready yet. No, it is not. See all the information here. Still doesn't know what's going on. It just found it out. So still, the smart state analysis hasn't kicked in. If we put a schedule maybe in the next 10 minutes or tonight, it will go and scan the content to make sure it's up to date. I could also see if the Elastic Load Balancer sees the JBoss backend as healthy. Listeners. Here. They're still not registered. Okay, have to wait a bit more. Let's see where the Ansible playbook is right now. It still says pending. Right now, it's in a lot of stuff. Postgres, OK, it's done. Now it should be registered. Voila.
There we go.
Working. So here's an actual application. I can buy the tickets, and it will write on the database and whatnot, right? So this is a service portal approach. It is not multi-cloud yet, because the demo I'm thinking is pretty simple. If I had done the network plumbing as I described and the storage part, then it would be fully hybrid, right? But this is the basic starting point. Next, this is basic. Next, I'm going to talk about interconnection and the challenge about it. Before we move on, any quick questions? And I should hurry up, taking my time. Any questions from what you saw?
So just to recap what we saw there again, we from a user portal, we requested that Ticketmonster application, and we showed you a lot of stuff working in the, we saw the sausage being made, but the user just waited 5 minutes, and then that all came up ready to go.
And I haven't enabled email because of spam and whatnot, but basically the user sees that it's VMs. So there are 3 Amazon VMs there, and I see what I created, right? And the moment it collects the CPU, I would see the CPU usage and whatnot. It's just too new right now. Anyways, this is a basic approach. Just expose one basic service. In order to make more advanced services, we have to connect the resources. That's another challenge, because every cloud vendor has its own SDN abstraction. AWS have the VPCs and the virtual private gateways. Azure also have their own gateways to connect each other. GCE also has its own technology. You can do peering, so you can get a direct connection to your Amazon or Azure. You pay for that as well, extra. They have to look at the cost factor, have to look at the security factor, and the flexibility one. You have to know how many regions you need, because each interconnect is different. So it's kind of another challenge beyond the one you have on the data center already. And let's say you go and start automating all that. You will see the templates that they offer to you. They all have their own language, like the Azure Resource Manager or the CloudFormation. So it's yet another system to know on the little knobs and security settings that you have. And in this case, this is taken from a sales kickoff demo where we did the networking. We're showing you how we're working with Ansible. So in the near future, you will be able to abstract what's the topology of your cloud, something similar to what you see here, in which you define the virtual networks of every cloud. What are the security settings, the traffic policies that you need, which traffic can go from which cloud to which other, in which order, the VPNs, how they connect amongst each other, how they connect to your main data center. Think about Active Directory, think about backups, all those things. You really want to put a policy on it, right? And define it in the same language, regardless if it's on Amazon or on Google, regardless if it's on the West Coast or in the East Coast. So with this abstraction that we did on the private cloud, we're mimicking what we have already done on the network automation, for which we have a demo later with, I think it's Patrick that does the network automation. We are abstracting the network details of the data center, so you have the same language to orchestrate a Arista switch or a Cisco router or a Juniper firewall, or Juniper would be another router, and the same kind of syntax. The goal of it is to have better business value out of your networking and security teams, which oftentimes are not seen as business value creators. Am I wrong? Sometimes network and security guys are seen as like the naysayers of the team. We're giving you guys the chance to bring them on board and automate their knowledge, have them a chance to provide value by connecting the clouds together and accelerating the delivery of new solutions and accelerating the solution and the remediation of issues, right? The mean time to repair, TTR. If you have automated the patching and the creation of a new VPN or the scale out to a different cloud for a burst scenario when you need more capacity elsewhere, networking guys are your friends. Without them, you would not be able ever to do burst. You see the workflow across clouds is the same workflow as you have today in your data center. Let's say I have a new project. First, I need to provision the instances, the VMs that do execute the software. I need to interconnect those resources, apply policies, and apply, let's say, a routing policy on a firewall, on an ADC entry for the load balancer, for my LTM policies. If there is VPN amongst my resources, all this workflow is kind of the same. And a demo we did during sales kickoff, and you can watch the video on YouTube, we did it from data center to Amazon to Azure, and the language in which that we use is the one that you will see later for Ansible for network. And we did things like configuring a checkpoint state, create the IPsec VPN, configure the VPN settings and the IPs on every region. So even if you have 10.1.00 on one side magically, automatically created, it will learn that and publish it internally, so you don't have to manually populate the routes. It will check the connectivity with pings and whatnot, and only return OK if all those steps have done properly, and if not, roll back. So that's something we demonstrated on that GitHub repo. So that's for the network part. Another thing we did demonstrate during sales kickoff was both data, hybrid data storage. We put Gluster on multiple clouds. We also put Fuse, Databird, on multiple clouds. And then the demo we did in sales kickoff was the data persistency of your game that right now is being hosted on Amazon. If Amazon goes down, the data is still there on Azure, and you keep playing, and your score was saved in memory. And that was a nice demo we did. Kind of complicated to replicate by a single person, but the technology underneath is as follows. They started with 2 separate islands of OpenChip. Each one of them had Gluster as the storage solution, and they created a geo-replicated pod volume. Those volumes are extending those that you already have, the data local pods that expose the local resources to Amazon, for instance, the local EBS volumes. You create another volume that is replicated geographically. That's best used for a write once, read many use case versus the read and write many things called on OpenShift. You have the storage profiles. So they played with that thing, and then they put Fuse on top so they could move the data endpoints dynamically. Again, this is thanks to Gluster. That's the open source name for Red Hat Container Native Storage, or Red Hat Gluster Storage as well. And it runs the same on bare metal, virtual machines, private cloud, public, and it also connects with your legacy, let's say Fiber Channel or any NAS or SAN solution. One of the benefits of doing that storage consolidation is that indeed you're actually using unused and wasted resources. On Amazon, for instance, you allocate a block on EBS, a 500 gigs, and that's what you pay. It's not per use, you pay per allocation. But what if it's empty? Well, Gluster could use that block that is attached to a web server. Web server doesn't use much storage, but regardless have the storage available, you could allocate that volume to the PostgreSQL storage that is sitting nearby and is reaching saturation. So you can see the picture of consolidating capacity. Another benefit would be if your container registry where you do your builds, not you, the developers, the guys in the other room. They are putting new versions like Flickr 10 times a day, right? 10 times a day they put a new application version. I want that software to be really available across all my clouds, right? Even if it's a 1 gigabyte big Word file with all my media content of my website, I want that to be readily available across all the clouds. So that's a benefit of this solution. It will expose the same container registry across all clouds. The moment one image is available on Azure, it becomes available on Google or on Amazon.
And we can also control the zones where they go, so you can protect your data locality.
Any questions?
So as of today, okay, if I'm automating the clouds to CloudFormation on AWS and resource manager templates on Azure. So so Ansible is sitting on an AWS environment and provisioning CloudFormation templates through that. Now in a hybrid cloud environment, where will my Ansible sit and how will CloudForm provision in both the environments?
Good questions. Where do you put these all? Where do you put Ansible? Where do you put CloudForms where you are orchestrating multiple clouds?
Ansible, because right now I have port 22 open to communicate. Ansible
Yep.
to push.
Ansible uses port 22, port SSH, to communicate, indeed, for Linux provisioning. When you go Windows provisioning, it uses different technology. When you use cloud modules, it uses the API calls to the public endpoints.
But now in a hybrid cloud, how will this work? With the
Same thing as, put yourself, Ansible, the moment you say, hey, Amazon, give me a VM, or give me a Elastic Load Balancer endpoint, it goes through a public HTTP endpoint to the public Amazon. Even if Ansible it's on Amazon itself, it goes to the internet to the public API endpoint and requests a new resource. So it's kind of, it doesn't matter where Ansible is sitting for cloud automation, because it will go through the internet regardless.
Okay, so you mean, okay, so I have that, I can provision my templates through Ansible on hybrid clouds.
Yeah, anywhere from your laptop, or my laptop.
And the other thing is the Redshift storage that you talked about. How do you, like, okay, I'm pretty used to EBS or S3 storage, like block or object. How do you put this storage to use, like, being accessed by all clouds?
Yep.
From an infrastructure point of view?
How would you put Gluster to work across all clouds? When, let's say, he knows EBS and S3. is the answer would be do not use the public-facing S3 from Amazon or the regular EBS storage. You boot up a Gluster instance. You say, hey, this is a EBS storage. He will connect to that EBS. This is a partition. I will mount it and put the file system. And Gluster exposes an S3 API, but with a private IP, 10.1. something. So you have to tell your tenants, instead of putting your bucket objects on the public cloud S3 and then secure ACLs and all that stuff, connect to this internal endpoint S3, 10.1 whatnot, put your buckets on your content there, and then expose that on the Gluster service as a public-facing S3 endpoint. So it's Gluster exposing only those buckets that you really need on a VPC that is public-facing. So it's Gluster the one doing your own S3. The advantage is that you will have that service on Azure as well, or on Google as well. So you don't of the S3 itself. S3 is an API as well. It's both a service from Amazon and an API language. You go to Azure, you don't have S3. I may be wrong on that one. Google has definitely a different language. They don't have S3. What if you want to use a Google volume, a hardware from Google Cloud Platform, but you would like still offer an S3 API for your consumers, your websites on OpenShift, to be able to put their images, their CSS, their files on the website on an S3 language. So that's a trick. You uniform all the storage providers. You leverage, let's say Google has better EOPS for SSD. Maybe Amazon for Glacier is very good for huge files that are archival only. Put Gluster on top. And Gluster will expose NFS, Samba, S3, or Gluster native block storage. Gluster exposes multiple languages, so they become the same. And then you bring it in-house. The message here is that you probably have way more data in-house than you have today on public cloud. Why move the data to the cloud? Just put an API on it. Put an S3 API, or make the access to that data using an API so you don't have to physically lift and shift the data. That's what the public cloud vendors, they want you to do. So they trick you. You can do machine learning. You can do big data and whatnot. Well, I can also do big data with open source tools on my cluster. I have recipes on OpenShift to do big data. But the hosting of that data and the data transfer are astronomical. That's something Paul mentioned earlier. Moving that data and keeping it there, they cost you money. Leave it where you have it today in your SolidFire NetApp cluster box. Put an API on it. And if the same API is available on Azure or on Amazon, makes sense. Right? And you can also enforce data locality to avoid network transfer costs because Gluster has data locality.
And it keeps you agile between, it gives you the choice. I use this term, you would never buy a car without reverse. You wouldn't even think to look if that had that spec. So by keeping your data local means that you can move between those providers depending on the price. The CFO comes, hey, Amazon's charging us too much. Then you can say, okay, well, we can move all our workloads over to Azure or to Google, giving that choice. If you move your data there, that becomes a very difficult choice. So put an API, keep it where it's most cost effective and makes the most sense for you to do that.
That's the same, one of the possible strategies is why you would justify putting OpenShift on every public cloud. They all have Kubernetes as a service, but they don't have CI/CD, they don't have registry, they don't have other stuff. We suggest using OpenShift everywhere as the same language of development for developers to do the same job regardless of the platform. And you can see with Ron the different solutions we have for doing that.
Yeah, so when I started with Red Hat over 3 years ago, one of the first projects I worked on, and I was very excited about it, was containers. It was OpenShift for our project. And why I was excited, because it really opened up a lot of opportunities for a customer, really enabled a lot of change and rapid adoption. It is making DevOps a reality in those customers. And so that choice gives you a lot of freedom. At the time, it was interesting for that project. The first one I worked on was, containers don't need to run on a VM. So I thought everybody would automatically choose to run it on bare metal. And then the first customer I worked on said, no, we want to run it on VMs because VMs is what our infrastructure is. And so the light went on for me is containers can run everywhere. And at the time, 3 years ago, the cloud providers weren't as prevalent and weren't as well developed. But now, what we're seeing with OpenShift is a basic requirement to be able to run everywhere, not just on bare metal, not just on VMs, on private clouds, but it has to run in all the private clouds. So what we're showing here is a slide where we're showing OpenShift running in AWS and all the integration points. We have integration points for theirs. OpenShift is a well-known platform, and us working in partnership with the cloud providers makes it readily available to be able to run there. And they don't mind integrating with us because there's no conflict there. We don't run a cloud. So they want to have people and companies like us that enable their technologies to run in the cloud. So they're seeing the uptake of OpenShift is very positive, so all of a sudden everything works well. Because you can't do this on your own, you have to work it in partnership with them. So we have AWS integration. We have Azure integration as well. We've made a lot of, I have a long history in the business. I used to work at Sun. In the days long ago, when conflict between vendors made good press, that was kind of interesting. It made for a lot of good newspaper sales. I know people don't buy newspapers anymore, but it made for a lot of good web consumption. But our customers even back then said, well, it made for interesting news, but it doesn't help me get my job done. Fast forward to today where you're seeing a partnership between us and IBM and us and Microsoft. Those things would have been unheard of before, but really it's all about, in the end, we really have to get all this, just get stuff done. So we have Azure integration as well. And we also have Google integration points as well. And we have all the things we need in there to make it be able to run there. Because it's great that we have a cloud management platform, but without the cooperation of the cloud providers, doesn't matter how good our product is, it wouldn't work for you. So we're doing all this work to make it enable you to run containers in every platform that you want. And including, it would be remiss if we didn't do that for our own private cloud, OpenStack, or the world's private cloud, I should say, not just ours, OpenStack. But one of those key integration points that we're putting into between OpenShift and OpenStack is integration with both the storage and networking. So those things that we were talking about before are built into OpenShift. So when we say OpenStack and OpenShift, hopefully we're not jumping ahead. OpenStack is our private cloud implementation of the open source OpenStack project. OpenShift is our implementation of Kubernetes and container technology to enable you to run containers. And it's more than just Kubernetes. There's many things that are included in OpenShift to enable you to run containers at scale in an enterprise. We could spend a whole day on each one of these topics, but we're talking about the integration of those today. So just an example of how that works is on your right, we see an implementation of networking in a private cloud. And what we're showing is we're showing two containers running in an OpenShift node. And we have a VXLAN, which is some encapsulation on each one of those pods. And then we also have a VXLAN in the infrastructure. And so what you're doing is you're doing that twice. And whenever you do anything twice, it's not very efficient, causes latency, causes slowdowns, and you're just using compute power for no real good reason.
By the way, that even though you may not notice, that's what you have on any other cloud. They do use encapsulation under the hood. You don't see it, because that's how I can run my own VM next to his with the same IP, but I don't know him.
Right.
Because we are being separated on the wire, on the cabling. They put tags, we have VXLAN or Geneva, their technologies to do so, but you just don't notice. I'm a tenant on Amazon. I don't know what's going on the cable, on the wire, but they do put the encapsulation thing that kind of reduces the overall performance you can get. When I do it on my private cloud, that's when I measure and I see, what are my 40 gigs per second? I'm barely getting, let's say, 5. That's because there's double encapsulation. We're working on what you see on your right side. Well, actually, we're delivering this very month. It's fully supported now. Something that bypasses the visualization layer and connects the pod networking of Kubernetes directly to the technology used by the hypervisor, in this case OpenStack. So you get like native networking on the container layer. That's something called Qt, it's a weird name. but basically gives you the same performance as virtualization networking. And we're also working, I actually have the product manager here with us today, on physical deployments of OpenShift with OpenStack bare metal service, but it runs OpenShift directly on bare metal. There is no encapsulation, so the packets are directly sent with, let's say, your VLAN header or without even isolation. But then it's orchestrated, so managed in the same way as your virtualization networking. So you get better performance with the same tools. So that's something we're also supporting today. It's OpenShift on bare metal, but managed with OpenStack. So it's kind of, get the best of both worlds, something that we're supporting this very month. Yes?
When you say VXLAN, do you mean VXLAN of VMware or VXLAN of OpenShift?
It's an example in this case. When I said VXLAN on OpenShift, that was the last release. Now we're moving to Geneva. And on OpenStack, you could have GRE, VXLAN, VLAN, or what was the other one? MPLS over GRE. It doesn't. It's an example, and the choice of numbers is also an example to make the point that double encapsulation is a real problem that you don't see until you try to get, let's say, 40 gigs per second of container networking, and then like, I just bought a brand new rack with 40 gigs per second, even 100 gigs per second backend, and I can barely get 4. That's because you put a packet analyzer, you will see double encapsulation. That's what we're getting rid of.
Container, we can run container without OpenShift. So why we need OpenShift?
So what was the question again?
For the container, we can run container without OpenShift, right? We don't have to have the OpenShift to run the container.
The question is, can you run containers without OpenShift? Yes, containers will run directly on Linux. Containers are Linux.
It's just a process, but there's no management of containers without Kubernetes. You just boot it one. And remember I showed you that I had like 1,000 containers on the other room? Good luck.
We get that question a lot, and what happens is that once the things you need to add, the service level, the self-service, all the vibrant community of things that you're going to use, like security scanning things, they all like to plug into a container platform instead of just straight containers. So it's all designed on that. And this afternoon, my good friends at Bell will be talking about their journey on OpenShift. And everybody starts there because they say, well, the developer runs into the room, I've got this container, why can't I just run it, just let me go. But then in production, there's many things that you have to do it. So people can start there, but eventually we see that they always come back to that they need more tools. They can either build those tools, all the open source tools themselves, or they can get the whole thing from us. So.
There is something called enterprise container.
The enterprise container, what your point, it's OpenShift. Everything containers and Red Hat is OpenShift because we deliver the full solution. Trying to chop it into pieces, there's a gap everywhere. So you will actually have to build it and whatnot. We're improving the package with the Tectonic acquisition. You heard about that. We bought Tectonic, what's CoreOS.
CoreOS, we bought CoreOS.
So we're making it more leaner and modular, and it updates by itself. Stay tuned because in a year from now, OpenShift will be like even easier to manage and just push button deployments, and it updates by itself. It will be way easier. So there's like no gap whatsoever. We should move on. We're time to check.
Okay.
And probably. Yes.
Do you have any voice recognition, natural language integration with OpenShift through Siri or Google Home or something that you could actually talk and just manage the container?
Question is if we have services like machine learning, voice recognition, and whatnot for OpenShift. Let me take that question with my other guys later, because those are the guys who will talk to you about application runtimes, things that we can run on top. Okay. Maybe actually the session that we have after lunch, maybe they can answer on stage that question as well.
Right.
Okay. We're going to explain what happens on the storage integration. We're going to make it quick because time check. OpenShift can get the storage for containers from OpenStack natively as well without human intervention, something that other solutions are way harder to achieve. We're just bringing that to you as well. So the storage automation, it's also a real value of using OpenShift on top of OpenStack, something that you cannot have with things like VMware, for instance. No, I don't think we'll have time.
Okay, won't have time. Okay.
You may get the slides. This is on YouTube, and there's a bunch of videos also on this.
So one of the things that we're talking about is with OpenShift, we're doing everything to make it work better with clouds, and we're going to show you on the next slide an example of a service broker for Ansible. So there's an Ansible playbook bundle that provides, a user can request an S3 bucket from Amazon. The broker starts, the Ansible playbook plays that, it runs this Ansible playbook, and then on AWS your bucket is created. This is a publicly, you can find this on Git.
Well, we're shipping this as part of the OpenShift runtime.
Yeah, we're shipping this as part of the OpenShift runtime.
So another example of how OpenShift exposes as well certain advantages of each cloud provider. So we know we recommend having a unified layer, homogeneous, like nobody knows where you're running. Sometimes there are services like machine learning and whatnot that you really like from Amazon or from Google and others don't have. We're giving you the way to, in a standard manner, expose and let your users consume that with an API that's standard. This is from the industry, that's not from Red Hat. Open Service Broker, it's a universal standard to do this. And we're using that language with Ansible for you to also change it if you want, to deliver those value-added services from each cloud vendor to your end user. Like bypassing this unification layer, sometimes you want to allow this extra service to be consumed, right? Why not? Sometimes it makes sense.
Everything we do has an open API and a command line, so everything's possible. So where to start? We heard Paul Armstrong start today say this can be complex, this can be hard, and while that's true, it may seem daunting. You also heard him say, just start. Yeah. So where do you start? Is that you can engage us and our global services team to help you, identify a business case. Take that business case and the drivers and the use cases and the challenges. Especially if it's you go to the business and say, here's a particular challenge where we haven't been able to deliver business value very quickly. It would be very good, highly visible to do that. And then go and identify possible technologies and solutions to use. We're talking about our products today, but sometimes there may be other products you want to be able to use in that. There's this healthy ecosystem of companies and products around this whole space that we partner with very well. And then we can help you create an action plan. And you heard Paul this morning refer to the term of teaching you to fish. We help you create a plan that you execute in partnership with us and our partners out there as well. And because unless this is done by your own staff, you won't get as much value. If you just have somebody come in and say, okay, we're going to install DevOps for you, that's not going to work. This is something that you have to adopt in your culture. So these projects, not only are they individually successful, but the people who get involved with them see the value of doing these projects in an agile fashion. It's one of the ways that we seeing great success. And so how do we do that? Is that we usually go help you with a discovery session. In the discovery session, we talk about what are your infrastructure requirements. We talk about what are the processes that you need to accommodate, and what are the workloads and apps. And this may be that you don't necessarily want to start with your first project to be a great big legacy application. It may be that you want to do that because it's identified as creating those pain points. But maybe you want to take something that's lighter. You don't even have to change the whole legacy app. Maybe it's the business unit wants this one new function on that app. Instead of rewriting the whole app to accommodate this one new function, maybe you just make that function a container function that calls into the legacy app, and then one by one surround that application with all the new functions, so that eventually you have you give it this bear hug of love of containers that will eventually make the original core less relevant. You want to design, and you want to know about the level of effort. You want to know about timelines. How long, how soon does it have to happen? And then you want to deploy this in a fashion that really makes it easy for your developers to work in an agile fashion. And we help you do all those things in a very structured fashion. We take and move it into this kind of 3-step process. We break it down to there, and we involve the right people. And we also created this book. Marcos pointed this out to me late last night. We have this book, and I hadn't read it.
Fresh off the press.
Fresh off the bit press, yeah. So this is and basically it takes those last 2 slides I talked about and expands on them and how you can make this work in your organization. It's really it really helps. So I think we're coming up on an end of time. Today, hopefully we've impressed upon you that hybrid cloud means containers everywhere. You can run them everywhere. You can manage everything with cloud forms. And if you're going to standardize on any one language for management, that should be Ansible for cloud automation. Because as we move from like tens to hundreds of VMs to thousands to tens of thousands of containers, we can't continue to manage it the same way we used to. And you'll see later in the other sessions today about how that will work with Ansible. But Ansible will help us do this for thousands and tens of thousands of things. We saw how we can interconnect data silos with common networking plugins and storage. And we showed you that OpenShift on OpenStack works great. And some of you at the audience said, we tried to do this before and it was hard. We've heard about people who failed doing this. And we listened. In my time when I was working at Oracle for a short time, Larry Ellison was on record saying, we can solve any problem because I have 10,000 developers working for me. And in the Red Hat world, you saw Paul's slide. There's millions of projects and tens of millions of people working on these problems in open source. So that means 2 things is you get much more relevant solutions because those problems aren't being solved for the profit of one company. They're being solved in the best way for the whole world. And they're being solved at a much quicker rate because millions of people can't compare to tens of thousands of people.
Let me double down that last comment. OpenStack in particular has come a long way. This month in June, we're launching the 13th release, 1.3. That's many iterations. Now it runs on containers actually. So the OpenStack services are all containerized. It's very easier to deploy, and it can deploy OpenShift on top automatically. Okay, and all those pieces that I described to you for high-performance network and high-performance storage, they all come out of the box. Okay, so if you tried it 2 years ago, give it a try again. It has come a long way. Without any other questions, thank you so much. You can go out for lunch.